everybody, so today we're going to be learning about fractions basics. So first we're going to do specifically the multiplication and division of fractions. First, multiplication. Well, I wrote out this little theoretical for you where a over b is multiplied by c over d. We're going to get ac over bd. Basically, when you're multiplying fractions, you're just going to multiply each of the numerators straight across and then put it over the product of each of the denominators. So a times c goes to ac, b times d goes to bd. Here's an example. 3/5 times 4/7. Well, 3 times 4 will go over there. 5 times 7 will stay at the bottom. Then we have 12 over 35. I like to make these little, rule boxes for things. You'll see them in a bunch of my videos. So the rules generally of multiplying will be 1, see if you can simplify. We'll talk about simplifying next. Then 2, as I mentioned, we're just going to multiply straight across the top and bottom. Now simplifying. How are we going to do that? Well, there's something called the greatest common factor, better known as the GCF. The GCF is the largest number that two different numbers are both divisible by, excluding 1. That's kind of weird put into words like that, so let's look at an example. The GCF of 6 and 9 is 3. So the greatest thing that can go into both 6 and 9 is 3. The GCF of 4 and 12 is 4. The GCF of a pair of numbers can be one of the numbers that we're looking at, because 4 goes into 4 one time, then 4 goes into 12 3 times. So now the rules of simplification. First, look at the diagonals numbers, the numbers diagonal to each other, to see if they have a GCF other than 1, because that won't really be beneficial. If they do, divide that number by the GCF, and now we're going to replace that as a fraction. So let's look at that in application. We originally had 3 over 8 times 4 over 6. The diagonals are 4, 8. So 4 is divisible by 4 one time, so we're going to cross it out and make it into 1. Then here, 8 is divisible by 4 2 times, turn that fraction into a denominator with a 2. Then we have 3 and 6, 1 and 2 times. So the new fractions really look like this. It really looks like we're multiplying 1/2 by, again, 1/2. Straight across, 1 times 1 over 2 times 2, which now equals 1/4. Let's try some examples of our own. So we have first 1/2 times 3/4. It doesn't really look like there's much to simplify here, so we'll just go straight across. 1 times 3 over 2 times 4 is equal to 3 over 8. Cool. Next. Nothing really to simplify either, looking at the diagonals. So we have 1 times 1 over 7 times 9, which is equal to 1 over 63. Great. 2/5 times 2. When a number doesn't have a denominator and it's just a whole number, we can assume the denominator is 1. It's 2 over 1, really. So we're going to have 2 times 2 over 5 times 1. 2 times 2 over 5 times 1, which is equal to 4/5. Next, it looks like we can start simplifying here. So 3 goes into 6 2 times and into 3 1 time. Can't really simplify this side. And it's okay that initially, or even after the simplification, the numerator is bigger than the denominator. It doesn't really affect our process for multiplication. So now we have 7 times 2 over the new 1 instead of 3 times 5, which is equal to 14 over 5. Again, okay, the numerator is bigger than the denominator. Next we have 3/4 times 6/7. The GCF of 4 and 6 is 2. 2 goes into 4 twice, and 2 goes into 6 3 times. Nothing we can do with 3 and 7, so now we have 3 times 3 over 2 times 7, which is 9/14. Eventually you'll get super quick at this and you can really cut out this middle step. Next, let's go to division before we do multiplication, division before we go to addition, because division is really similar to multiplication in just we switch one step. So in division, we're going to take the first term and we're going to multiply it by the reciprocal of the second term. Reciprocal, that's a new word. Reciprocal, also known as a multiplicative inverse, basically means when the number is multiplied by its reciprocal, it equals 1. what the hell does that mean, right? So the reciprocal of 3/4 is 4/3. You basically just flip the number. So here we go. If we have an example, 3/4 divided by 5/7. So it's the same thing as multiplying 3/4 by the reciprocal of 5/7. We're going to flip it. So now the 7 is on top and the 5 is on bottom. Now we're just going straight across again, just like last time. 3 times 7, 21. 4 times 5, 20. There you go. So here are our rules, just to make sure. Take the second's reciprocal. Flip. We're going to flip the second. That's all that means. Second, see if you can simplify again, because basically after step 1, it's the same thing as multiplying. The same step as multiplying. Then we're just going to multiply straight across. So let's do some examples again. 1/2. Now we're going to times it by 4/3. Look at that, we can simplify. 2 goes into 2 one time, and 2 goes into 4 2 times. Now we have 2/3. Great. Now we have 5/2 times it by, we're going to flip it, 4/15. Let's simplify. 5 goes into 5 once, and into 15 3 times. 2 goes into 2 once, and into 4 twice. Now we have 1 times 2 is 2, and 1 times 3 is 3. Again, remember, there's an imaginary 1 if you have something with no denominator. We're going to flip it though. So 3/8 times it by 1/7. Nothing really to simplify here, so just multiply straight across. 3 over 8 times 7, 56. Keep going. We're going to flip it. 3/7 times 2 over 0. Well, if we multiply straight across, we got 6 over 0, but this is not a real number because you can't have the denominator as 0. So this is not a real number. Next we have, let's go back to our purple, 5/4 times it by 8 over 1. Let's simplify. 4 goes into 4 goes into 4 once, and into 8 twice. Then we have 10 over 1, which can be simplified to just 10. There we go. Let's move on now to our addition and subtraction rules. The same rules really apply for addition and subtraction both. So we have a new term, just like we have GCF, we have something called the LCM, the least common multiple. So the least common multiple is the smallest number that two different numbers are both fractions of. So let's look at examples, because examples always help. The LCM of 5 and 3 is 15. 15 is the smallest number that has both 5 and 3 as factors. The LCM of 2 and 4 is 4. Just like with the GCF, the LCM can be one of the pairs of the numbers. So here's a major rule. To add and subtract, we need the same denominators. How are we going to do that? Let's look at our rule box. The denominator needs to be the LCM. We're going to multiply each individual fraction by the value of the LCM and divide it by the original denominator. Wait, what? Don't worry, we'll go into that. Then we're going to add and subtract across while keeping the same denominator, and then we're going to simplify. So first we need to identify the LCM. Let's look at this example here. 3/4 plus 5/6. What is the LCM of 4 and 6? Well, the LCM of 4 and 6 is 12. So now we need to make 12 the denominator for both of them. How are we going to do that? If you multiply any number times it by something that's the same number over something, for example, 3 over 3, 3 over 3 is equal to 1. Same here, 2 over 2 is equal to 1. Any number over itself equals 1. So if you're multiplying by that, you're not changing a thing. So, therefore, 3/4 is equivalent to 9/12, but we now have the new denominator that we need. Then we're going to do the same thing with 5/6. We need to make the denominator 12, so we have to multiply everything by 2 over 2. So 5 times 2 is 10, 6 times 2 is 12. Now we have these new equivalent fractions. this was equal to the original, and this was equal to the original, but now we have this sought after denominator. From here, we're just going to add straight across while maintaining the denominator. So 9 plus 10 is 19. Maintain the denominator is 12, 19 over 12. This is our solution. So let's practice this a few times. So 2/5 plus 3/10. What denominator do we need? Well, the LCM of 5 and 10 is 10. So we're going to have to multiply 2/5 by 2 over 2. So 2/5 times 2 over 2, so that 5 times 2 can equal 10 in the denominator, plus 3/10 is going to equal 4/10 plus 3/10. Whoops, I'm running out of space. Sorry, guys. We're going to bring this down, add straight across, we get 7, keep the denominator tenths. Great. I'm going to write this above so we keep enough space. This goes to 7/10. Cool. Next one. We have 4/7 plus 1/2. What's the common denominator here? Well, we need the LCM to be 14. So we're going to have to multiply this part by 2 over 2. Then we're going to have to multiply this part by 7 over 7. Then we have the new fractions of 8 over 14 and another new fraction of 7 over 14. Add straight across, we get 15. Keep the denominator 14. 15 over 14. Now remember how I said that the rules for subtraction is the same as the rules for addition? So we need the LCM of 3 and 2, which is 6. So we're going to have to do 2/3 times it by 2 over 2 to get the denominator to equal 6, minus 1/2 times by 3 over 3 to get that 6 in the bottom again. Now equals 4 over 6 minus 3 over 6, which is now equal to 1 over 6. Ooh, now we have a negative sign in the front, so we have to keep an eye on that. The LCM of 2 and 5 is 10. So we're going to have to multiply negative 1/2 by 5 over 5, then subtract 4/5, and then we're going to have to multiply by 2 over 2 to get that 10 on the bottom. So now we multiply. Negative 5 on the numerator over 10 minus 8 over 10 on the bottom. We're going to subtract straight across. Negative 5 minus 8 is negative 13. Keep the 10 on the bottom over 10. Now, remember, keep that negative in mind. The LCM of 4 and 9, that's a big one. Let's think. LCM of 4 and 9, I believe, is 36. So, we're going to have to multiply negative 3/4 times it by 9 over 9, add it to 5/9 times it by 4 over 4. Now we have on the top over here negative 27 over 36 plus 20 over 36. Add straight across. Negative 27 plus 20 is negative 7. Keep the 36. Negative 7 over 36 is our solution. Hope this video helped out, guys. Tune in for the next one.